Welcome to Prime Cyber Insights. I'm Noah Feldman. Today, we're looking at a development that, well, it feels like it's been plucked straight out of a science fiction novel, but it's actually sitting in a lab right now at the Flatiron Institute. It involves the Fibonacci sequence. You know, that mathematical pattern we see in everything from sunflowers to pine cones? And it's doing something pretty incredible to quantum computers.
It really is quite extraordinary, Noah. Good to be here. I'm Sophia Bennett. What we are discussing is a study recently published in Nature where physicists used those Fibonacci-timed laser pulses to create, essentially, a completely new phase of matter. From a global infrastructure perspective, this isn't just some physics curiosity. It's a potential solution to the qubit quandary that has held back quantum supremacy for years now.
Right. And for those who maybe need a quick refresher, the qubit is really the heart of quantum computing. Unlike a standard bit that is strictly a 1 or a 0, a qubit can be both simultaneously. But they are notoriously finicky. Even a tiny change in temperature or a stray vibration can cause them to lose their state. It's really the biggest hurdle we face for the future of automated labor and high-speed data processing. It's why we don't have these machines in every office yet.
Exactly. Usually, a qubit at the end of a line of atoms might stay stable for, say, about 1.5 seconds. But when Philip Dumitrescu and his team blasted those atoms with lasers mimicking the Fibonacci sequence, where each number is the sum of the previous two, the stability jumped to 5.5 seconds. That is a massive leap forward.
Yeah, that's nearly a 300% increase, which is just massive. And the reason why is almost poetic in a way. Dumitrescu said that by using these quasi-periodic sequences, the system behaves as if there are two distinct directions of time. It's like the computer is operating in a higher dimension of stability.
From a formal standpoint, this quasi-crystal structure in time creates a pattern that is ordered, but never repeats. This lack of repetition is really the key here. It effectively cancels out the errors that typically occur at the edge of the quantum system. It keeps the information coherent far longer than we previously thought possible.
And for our listeners in the digital economy, this is what we call the unlock. If we can maintain quantum states longer, we move so much closer to computers that can break any current encryption or simulate entirely new materials in seconds. It changes the labor landscape entirely, from pharmaceutical research to how we approach financial modeling. It's a total shift.
Totally. It also raises significant questions for international law and diplomacy. If one nation masters this Fibonacci stability first, the current standards of global cybersecurity are essentially rendered obsolete overnight. It's a race for a new kind of digital sovereignty.
It's a powerful reminder that sometimes the most advanced future tech relies on the oldest mathematical patterns we know. The Fibonacci sequence has been around forever, but it might just be the key to the quantum age.
A fascinating intersection of nature's patterns and human ingenuity. Thanks for joining us today on Prime Cyber Insights. I'm Sophia Bennett.
And I'm Noah Feldman. We'll see you in the next episode. Neural Newscast is AI-assisted, human-reviewed. View our AI transparency policy at neuralnewscast.com.